Here in Section 3, we use synthetic division quite a lot. So if you need to review the synthetic division, go look at the Section 2 video. So this is simply asking, is the x plus 4 a factor? So if x plus 4 is a factor, this x to the 4th power means there are 4 factors. X plus 4 would be one of those. So we'll use synthetic division. Notice in the beginning, however, we start with x to the 4 and then we jump to x squared, and there's no x to the 3. So we need to compensate for that whenever we write out our coefficients. Here's the 3 from the x to the 4. Here's the 0 for the x to the 3. Then negative 48, and then 8, and then 32. Now x plus 4 means we use negative 4 in synthetic division. And so we're simply wondering, do we come out with a 0 in that spot? So here's the process, synthetic division from Section 2. We add, multiply, add, multiply, add, multiply, add, multiply, and add. And so our answer is, yes, it is a factor. Here we have the same sort of question, just a little larger polynomial. So the synthetic division would be for x to the 5, the 1 on the front, and then 6, 11, 12, 5, and negative 20. And our front number is negative 4. Add, multiply, add, multiply, add, multiply, add, multiply, add, and multiply. Negative 20 and negative 20 is negative 40. So this is not a factor. Here we're going a little bit farther in that we are told that we need to factor this. Now since this is an x to the 3rd, we know that we're going to come out with 3 factors. They tell us that 5 is a 0. So we should be able to write x minus 5 as one of the factors. Now, not that we don't believe them, but sometimes we don't. We're going to actually test the 5 using synthetic division. And make sure we do come out with a 0 at the end. So we'll add, multiply, add, multiply, add, multiply, and add. So they were correct. 5 is a 0. Now, the most important thing about doing the synthetic division is what's left here, once we get rid of the 0, is the quadratic 6x squared minus 7x minus 3. We need to solve that quadratic equation. Now, there's several ways of solving a quadratic equation. We could factor, or we could use the quadratic formula. Better yet, we could use the quadratic formula program that we put on our calculator before spring break. So if you have such a thing, here's what it would look like. In addition to the x equals 5, we now know that we have x equals 3/2 and x equals negative 1/3. So those would be our 3 zeros. The x equals 5, if we subtract 5 from both sides, gives x minus 5 equals 0. So the x minus 5 is one factor. If x equals 3/2 and we multiply both sides by 2, we get 2x equals 3. If we subtract 3 from both sides, we get 2x minus 3 equals 0. So 2x minus 3 is a factor. Similarly, if x equals negative 1/3 and we multiply both sides by 3, we get 3x equals negative 1. If we add 1 to both sides, we get 3x plus 1 equals 0. So the linear factors would be x minus 5, 2x minus 3, and 3x plus 1. We have the same relationships here. We are just reversing the process. We are told that we have zeros, negative 3, negative 2, and 5, which means for negative 3, x plus 3 would be a factor. For negative 2, x plus 2 would be a factor. And for 5, x minus 5 would be a factor. The other information that we have is that if we substitute a negative 1 into our function, we're going to get an answer of 6. So, in addition to all of these factors, we could have a number out front. I'll use an A to represent that. And so our function would be some number times those three factors. Now we're told that if we use a negative 1 in place of the x, that would look like this. Then we're going to get a 6 as the answer. So let's do this calculation. Negative 1 plus 3 would be 2. Negative 1 plus 2 would be 1. Negative 1 minus 5 would be negative 6. If we multiply those together, we get negative 12a equals 6. If we divide by negative 12, we get a equals negative 1/2. So our function is a negative 1/2 times x plus 3 times x plus 2 times x minus 5. Now that should suffice as an answer. However, we may need to multiply that out. This is a lot like the previous one. We're told that we have a 0 of 4, which means x minus 4 is a factor. We're also told that that is a factor 3 times. And like the previous one, we're going to assume that there may be some number here. And we're told that if we use a 2 in place of x, we get negative 24 as our answer. So let's use a 2 in place of x. And figure out what a is. So that's negative 2, negative 2, negative 2, which comes out to be negative 8. And that comes out to be a positive 3. So the function we're looking for is a 3 in place of the a, and then we can compactly write those x minus 4s as x minus 4 to the third power. So like the previous two, this time we're told negative 4 is a 0. So we know that we have an x plus 4 as one of our factors. We're also told that 3 minus I is a 0. So the factor for that would be x minus 3 minus I. Now there's also a property concerning conjugates. If 3 minus I is a 0, then 3 plus I is also a 0. And that would be x minus 3 plus I. Now, since we're supposed to be writing this as a polynomial function, and that is not a polynomial function with all the i's in it, we need to simplify this sum. So we're going to take these and multiply them out. So this first factor is x minus 3 plus I when you distribute the minus sign. And the second factor is x minus 3 minus I. Now when we multiply those out, we would multiply these x's together. They would multiply the negative 3 and the x, and the x and the negative I. We would multiply the negative 3 and the x, the negative 3 and the negative 3, and the negative 3 and the negative I. And we would multiply this I times the x, this I times the negative 3, and the I times the negative I. Now you can see some of these will combine together. The x squared has nothing to combine with, but the two negative 3x's can be combined together. The negative xi and the positive xi will subtract out, as will the 3i and the minus 3i. We've done this before. The I squared is negative 1, and the minus on the front of that makes it a plus 1. And 9 plus 1 is 10. So when we multiply that out, we no longer have any i's. And so this would be our polynomial. And again, we may need to even multiply that out depending on how the answer is wanted in my math lab. Unlike in previous problems, we haven't been told on this one what any of the factors or zeros are. So we're on our own. We have a couple of choices. One, we can use our calculator, which I'm about to do, or we could do this the old-fashioned way. We can list all the things that divide evenly into 50. That would be a 1, 2, 5, 10, 25, and 50. We could list all the things that divide evenly into 1. That's pretty easy since that's just a 1. All the combinations of these numbers over these numbers would be 1, 2, 5, 10, 25, and 50. And we could have the positive or the negative of each one of those. So you can just start trying those and mark them out as you go, using synthetic division, that is. Or you can use your calculator. Now on the TI graphing calculator, we would choose the y equals, type in our function. We'll look at the graph to get an idea of what we're looking for. I'm really thinking that on this graph we're going to have answers of -5 and 2. And sure enough, that was in our list of numbers that we mentioned just a moment ago. So then we're going to look at the table. Now, the table is what's definitive. And you can see here, for 0, we've got a -5 and a 2. So, we know that x equals -5 and x equals 2 are zeros. We'll do synthetic division. Starting with the 2. And sure enough, that was correct. We'll mark out the 0, do synthetic division with the -5. And sure enough, it was okay. So now, as before, we need to take x squared minus 4x plus 5 and solve that quadratic equation. And again, the best way of doing that is with the quad program on our TI graphing calculator. If we don't have such a thing, however, we will need to use the quadratic formula because this does not factor. Now, I'm going to leave it up to you to actually do the solving of this. However, here are the answers. We have x equals 2 plus I and x equals 2 minus I. So we knew in the beginning we should get 4 answers, and here they are. We have a -5, 2, 2 plus I, and 2 minus I. Now, it doesn't matter what order we enter those in.